Alright, hey guys. So, haven't recorded a video in a long time. Today I'm just going to do a challenge. I'm not going to test a code. I'm just going to submit right away. And then if I fail, I fail. Let's see how I do. Of course, maybe I just don't, maybe I just never, and maybe I just don't AK this round. We'll see. I don't care about my rating at this point. But this is NeoVim. So I just I recently went from VS Code to NeoVim, and this is my first contest with it, and let's see how it goes. Bruh, oops. Oh shit, I forgot. Okay, let's read this. See what happened. 6-2. So it's 3. Oh, 0, 1, 2, 3, and then 3, 4, 5, 6. So this is also I feel like I just felt the felt the challenge because I ran the code, I tested the code. So but let me just make sure I don't make the mistake. So string to int hours for times 60. String Oh my god, okay. I see. Okay. At least it didn't give me a wrong answer. I gotta remember not to do that again. I just tested the code. So you must process the elements of the elements from left I. To process the ith elements, you need nums I resources. If your available resources are less than nums I, you may perform an operation that increases your available. Like k, the value of k is fixed and does not fruit. Okay, after processing the ith element, your available is. So initially we have k, but wait, what the hell? the minimum total cost required to process all elements. The first such operation costs 1, 2. Okay, I get it. So, alright, let's see. So suppose I have less than it, then I just do this. So I seal the need, and I increase the operations that I need, and then increase it, and then subtract by the current, and then I kind of just mod, right? And then just in case, I'll do this first. Okay, so the answer is, I output 12, the answer is 1. So let's say we have 1, 2, I increase once. So if I have enough, then I subtract, it gets to 1. Oh shit, we don't actually need this. So subtract. So let's see, so we have 11, 11. We have 1, 1. So that's 2 when I get here. And I need 2 of that, 2 operations. So that's going to be wait, so that's 2 and then 5. Wait, shit. So that's 2, 5, 4, 8. 2 plus 8 is 10. So 10, that's 3. 7 minus 2 is 5. 5 plus 3, 8. 8 divided by 4 is 2. Yeah, okay. Oh shoot. It's also too big, right? I should have used Should have used Python for this. But it's fine. Let's see. So it's because of this calculation, it exceeds okay. Okay. Let's stop being so cooked and make less mistakes. So this is construction. I prefer having n as rows and m as columns. So let's do that. So I'm just going to create a board like this, right? Or a grid like this. Suppose everything is free. Okay. And then obstacle. So valid. So exactly k valid paths. Is the next one? Okay. I thought it's going to be a part 2 to this. So okay, so k is really small. So exactly k valid paths. So suppose we just want one valid path, then that's pretty easy, right? So let's try to brew first, because let's try to do case analysis with this. So suppose k equals to 1, right? Then I want to make the whole entire top right section just blocked, right? So let's do it something like this. So like that, right? So like that, and then same with no, that's this is going to be 1. Okay, and then this is going to be enough for k minus 1. And then for k minus 2. Okay, this I might be getting a lot of wrong answers because I might be making any, like, bad mistakes. So if k minus equals to 2, then suppose if k equals to 1 or m equals to 1, then this is not possible. So return so what is it, empty? Okay, and then let's do this. So we're just gonna make the center area. So this is going to be yank this and then paste this in center area, so this and this one, and then so they could only go from the side, right? If they could only go from the side, then that's exactly 2. Let me just return grid out interface. Okay, it can only be this one. So so this is pretty easy, right? So assuming they have, let me see, so 1, 2, 3. Wait, 1, wait, 1, 2, and then 1, 2, 3. So what I could do is I could make it all go the same. Like let's say, let's see if I have my whiteboard. So suppose this is a board, right? Suppose this is a board, and we're gonna assume that n and m is greater than 1, right? So this is gonna be one route. Then I could add another route just by unblocking this area, and then I could add another one by unblocking this area. So technically, this is technically I could do it with like all 4 of these, right? So as long as let's see. So if the max, sorry, if the min, wait, so for all of these, they have to be for k greater than 1, they have to be greater than 1, right? They have to be greater than 1, and then once they are greater than 1, we could use the longer side. Let's see. Yeah, we could use the longer side. So let's say this uh this is the longer side. So the longer side refers to like this is n, this is m. So n is greater than m. So we're gonna create one route over here, right? That's 1. And then we could create another one over here and over here. Yeah, like that. So it's basically at m minus 1. Well, actually, is it like that? Let me see. So I could actually, yeah, actually it is, it is. So instead of like doing it like what I do, at the longer side, we could always just add it over here, right? We could just always add it over here. Yeah, and then that should be it, right? So n equals to if max of mm is less than 3, then return wait, let's just make the whole entire thing the whole entire yeah, let's just make the whole entire thing locked, and then we construct the path. So it's going to be grid 0 and this one is fine. And then this one, we're just going to add it to this 0 is good. So this is grid 1, grid 1, and then m minus 2 equals to 3, right? And then this one is grid 1 m minus 2 equals to grid 2 m minus 2. But we have to see if n is greater than or equal to 3, then this is fine, right? Oh shoot, sorry, I just I just started using them, so I didn't know how to move it up. So otherwise, it's going to be flipped over, right? So but otherwise, let's see. So this is what we're saying, n is greater than m. Otherwise, if m is greater than it, then it's going to be something like, right, it's going to be like this. And we just did this, so we could always just do this, right? M is greater than m, so like this, and then this is not right? So let's say we have a 3 by 3. Let's say we have a 3 by 3, right? Wait, actually, what is it? 2 by 3. Or 2 by 3. So this is 1, 2, 3, 1, 2, 3. So that's 3. Okay, so 2 by 3 is whatever. So what about 3 by 3? So over here we have, so I think we have to deal with the 3 by 3 case manually. So 1, 2, no. Okay, what about, just here? What about just this? So, 1, 2, 3, 4. Oh, but this is fine. Is it possible? So 3 by 3. 1, 1, 1, 2, 1, 2, 3. Wait, this is it, right? So 1, 2. Wait. No, that's not it. 1, 2, 3. Yeah, I don't think that's possible. Whatever. If it's wrong, then it's wrong, right? So well, whatever. Submitting this. Okay. What? Wait, why did I block the last one? Wait, what? Okay, 0, 1, n minus 1. Wait, what the hell? Wait, what the hell? Wait, what? I'm trolling. Wait. So this one, and then n minus 1, and then. Oh, shoot, I'm trolling. Okay, so let's see. This one was the one that I was worried about. So okay, so you could do it. Whatever. I guess I'm just gonna brute force it. Or why is this still what the hell? What? I thought that's what I did. I must accidentally press the button or something. So let's say there are 4, right? 1, 2, 3, 4. So n is greater than. Oh my god. So if n equals to 4. Okay. Okay, this is this is pretty chopped and brutal. I don't know what I'm doing. But it's fine. At least we got to the last question. Oh, holy shit, that was so unbearable. How much time do I have left? Okay, I can't believe those 3 easy questions took me 28 minutes and like 10 million penalties, but it's a challenge, right? So but at least one column must remain. The relative ordering of the remaining ordered columns must preserve consistent for every row I and for every pair of adjacent remaining columns A and B. With A less than B, the following holds. So for every pair of adjacent remaining columns, what the hell? You may remove 0 or more columns from the grid, but at least one column must remain. The relative ordering this is a but this is kind of hard. How big is the oh okay. I think I could do something like a n times m squared. Since this is just adjacent, right? So suppose if j equals to 0, dp. So these could all be itself, right? So I could skip this for now. Good. True. So it's good as long as, let's see, if grid ij, the absolute value of grid ij minus grid ik less than equals to limits, right? Then dp j equals to max of dpj and dpk plus 1. Oh, sorry. Else good equals to false. And then if good, then we do this shit, right? This is fun, right? It seems fun. Yeah, okay. I can't believe so I can't believe the Q4 is the only one that I didn't get a wrong answer on. I mean that Q4 is really easy. I don't know what that Q4 was doing. Thank you guys.